Hello, welcome to SMT call. Today we are going to solve the day 5 of August LeetCode challenge. So today's problem name is add and search word, and we need to design one data structure for the same. So basically it's saying that if you read the problem statement, it's saying that we are going to perform. So our data structure should have two methods. One is for adding the words, another one is searching the word, right? So basically we need to create one data structure in which we are going to store our words, kind of dictionary you can say, and we are going to search the word from our data structure also, right? So we need to implement two methods, right? Okay, so you can go through the given example also. It's saying that suppose we added 3 words in our data structure, bad, dad and mad, then again they are searching with pad. So pad is not exist, then we need to return false, right? So similarly there are some condition here also, or note kind of things that they can search with dot also, right? So dot means we need to ignore the first. So suppose for this example, right, dot ad, so that means we need to ignore the first character, right, dot. So that can be anything, so we need to search with ad only, right? So yeah, in this case we know that it's returning true, right, because we have ad in multiple words, right? This word also, right? So means that word is exist, right? So in that case return true. But if you check this word, this is also exist, right? So we can see that b is exist here, then we can have two dot, right, ad, we can have the combination, right? So in that case again we are returning true, right? But in case of pad is not there, so we are returning false. So that is the example. That's pretty straightforward. So how we can solve it, right? Using Java today. So there are multiple approaches. So let us solve using the first approach. So that's a pretty simple or pretty straightforward, we can say. But its runtime is better than other approach. Okay, so how we can solve it? So basically what we can do, so we can create, so we need to take one data structure, right, in which we are going to store this thing, right? So probably I think the best thing will be that if we can take one map, right? So probably we can take one map, hash map or anything, okay? And in that map we are going to store our values, right? So in the map we have two things, right, key and value. So our key in this case, probably we can make the length as our key, so it should be the length, and I am going to store it in a list, right? So in the list I am going to store all the words, right? So words. So basically suppose in this case we have one word, right, bad, so its length is 3 and we are going to store it here only, right? Similarly for dad and mad, right? But suppose in this case my length is 2, we are going to store it in the for 2 only, right? So basically according to length we are maintaining the key value pair, right? So we can do that like that, right? So probably think it like a map only, and again for each and every length we are maintaining separate list, right? So it will be like this. So this is the list for this, and this is the list for last one. Okay, so how we can proceed now? So basically we can see, okay, bad is my length is 3, right? So I can do, I can insert bad in this corresponding for this 3 key, right? Again I can see dad, again that's length is also 3, so I can insert it here. Okay, then after that I have mad, I can insert it here, right? After that I have 2, so in this case my length is 2, right? So I can insert it here, right, 2. Okay, so after that we have from, so in this case our length is also 4, right? So we need to create separate key for the same, and I am going to insert from here, right, for the 4th key, and at the end we have cricket, right, cric. So in this case we have length of 6, right? So word length is 7, sorry. So in this case we are going to insert cricket word in 7th key bucket, right? So, okay, so this is how we can create our data structure, right? So this will be a data structure in which we are just storing those words, right, corresponding to its length. So basically we can use any map, right? So now how we can search it, right? So suppose I want to search pad here, right? Then how can we search it? So I will at first check, okay, is that length exist? Okay, I can see, okay, I have in my hash map I have a key with 3, right? So I can pick that one or get that corresponding list for that key, right? So, okay, in that case after that I can iterate through here, right? I can iterate through each and every string, and I can found, okay, is that word is matching with our word which is in our memory. If it is matching, then we can return true, else we can return false. Okay, but we need to consider dot also, right? So whenever I will see any dot, in the meantime I can ignore that position, right? So suppose b, so I am going to check this one, right? B double dot or B double full stop. So how we can do that? So at first I will check my length, okay, it's 3, right? So I will come here and I will check, okay, I will now check each and every word with this given word true, right, with this given search word, right? So at first I will check the first character, it's matching, right? Then I will find, okay, I have dot. In that case I can skip it, right? I can go forward. Again I will find, okay, again I have dot, and in this case I can go forward, right? So I can, after that, if it is not returning false, then you can return true, right? That means that word is, particular search word is exist in our dictionary, right, or in our map. So this is how we can solve it. So let's solve it using Java, and you will understand better also after seeing the code. So what we can do, so as I already told you, so I am going to take one map, right? So let me define that map. So its key will be integer value, actually its length, and I am going to take list, right? So for each and every length I am going to maintain a separate list, right? So it should be list of string. Okay, so let me name it as map only. Now what I will going to do, so I am going to do initialize my map, right? So it should be map equals to new hash map, right? So whenever we initialize our class word dictionary, we are just going to initialize our actual map, right, in which we are going to store. Okay, now what I am going to do, I need to add it, right? So adding is pretty simple. At first we need to check that that particular length, word dot length, is exist or not in the map, right? So let me take, so what I will do, map dot get map dot contents key, it will check that this particular length is exist or not in our map, right? So if it is returns true, then what we can do, we can just get the value map dot get. So it should be map dot get word dot length, right? So and whatever it will return list, right? And I am going to add my word there only, right? So it will be like this only. And if it is not content for the first time, right? So we need to create one new list, right? So it should be list, it should be string, and let me name it as L only, and let me define one array list. Okay, so it should be an array list, and it should be a generic type. So okay, now I need to just add my words in this list, right? So L dot add, and it should be word. Okay, now once we are done with this list, once we are done with the adding in this list, then we need to just insert in our map, right? So map dot put, and again word dot length, and I am going to add this list value, right, in that corresponding map. Okay, so this will be, I think this is enough for adding, right? So we are just checking the length and we are just inserting in that map, right? Okay, now I need to write logic for searching, right? So we are done with our addition. Now we want to search, right? So how we can search it? At first I can check that, okay, is my map contains that particular length character. Suppose I am searching for 10 and a character of length 10, right? So we don't need to go further, right? We don't need to go further to our map. At first we can check that, do you have any entry or do you have any key of length 10? If not, then we can directly return false, right? So we are going to write that only. So map dot contents key, contents key, and if it is contents key, then we are going to perform our logic, else we can return false, right? If it is not matching, then we can return false. Now if I see, okay, I have, so suppose I am searching any pad 1, right? So I have one word, right? So I have length for 3, right? I have key for length 3, right? Now I need to fetch the list for the corresponding key, and then I need to search, right? So let's do that. So how we can do that? So at first I will take those in a list. So it should be one string, list of string, and probably what dictionary WD equals to map dot get, and for that particular length, right? So once we get our list, then I need to run one for loop there, right? So it should be an string str, and it should run on WD. Okay, what dictionary. Now I need to define some function, right? So probably I'm going to define one function, compare words, something like this, to check the actual equality. And I need to pass two things, right? I need to pass my actual word to search, and I need to pass my that word in our dictionary, right? So we need to check for each and every string, right? Or each and every word, right? So I need to pass that corresponding word. Now what I need to do? I need to implement or add this function, right? Compare words. So basically, let us define that also now. So it should be an private method, and its return type will be obviously Boolean. So it should be Boolean, and let me name it as compare word, and I am going to pass two things. One is the word to search, and another one is the corresponding word present in the dictionary, right? in which we are going to search it, right? So search should be, let me name it as str only. Okay, now I need to compare it, right? So how we can compare it? So I need to run again one for loop in C equals to, I need to start from 0 position. Now I need to do what I need to do. I need to run it till C is less than what dot length. So basically you can take either what dot length, or you can take str dot length also. Basically both are in this case both string has same length, right? It will be 3 and 3 only, and I need to increment my C, right? Now what I need to check, so at first I need to check that if my word dot char at C equals to full stop, right? That means we should continue, right? We should not check the equality of the character, right? We should continue. Okay, else what we need to do, let me copy it, and okay, it should be semicolon, fix that. Okay, else, or we can directly write if also, right? Since we are using continue. If what dot char at I not equals to str, right? It should be str dot char at C, right? Char dot at C and what dot char at C and str dot char at C is not equal, then we can directly return false. That means what is not matching, we don't need to search further, right? So it should be return false, right? Now okay, and if it is not, so if it is come outside of our for loop, then that means the word is matching, right? So we can directly return true, right? Okay, I think that's pretty much for this function. So basically using this function we are checking the equality, right? And we are ignoring full stop here, right? Or dot. Okay, now let's go back to our actual implementation, search implementation. So what I will need to check, so if this compare words returns true, then that means our word is exist, right? We can directly return true. We don't need to check the other words, right? So suppose it's matching with the first word only, right? Then we need to go further. We can directly return true from there only. Else we need to go through again the whole for loop, and if it is still not returning anything inside this for loop, then we can assume that word is not present in our dictionary, right? We can return false. Okay, I think that's pretty much for this code. Let's run it and check whether it's compiling or not. Yeah, I think it's throwing some error. Okay, let me fix that one by one. So at first there should be one and closing one, and there should be one semicolon also. Okay, anything else did I miss? Okay, I think there was one spelling mistake. It should be okay. Now let's run it once again and check. Okay, I think there should be another okay, there should be another closing bracket. I think it's good now. Let's run it once again. Okay, so basically I fixed all the lengths. Now it should compile, hopefully. Okay. Yeah, I think it's giving me the expected answer. Let's submit our answer also and check. Let's check the time complexity if it is accepted. I think it's accepted. Now let's check our time complexity also, and I think it's beating most of the Java solution, and memory use also is not that much bad, right? So this is the one approach. So basically let's give me the code walkthrough once again, then we can discuss another approach. So I can discuss that approach and you can implement that in your own, right? So basically what you are doing here, so we are maintaining one map, so as part of our dictionary memories, and we are maintaining a list for corresponding key value. So basically it's a key value pair. Key is our length and value is a list, right? List of words for that length. Okay, so basically and then whenever we are searching it, so we are just checking that if that length is exist or not in our map. If the length is exist, then we are checking each and every words for the corresponding key, right? And we are whenever we encounter any full stop, then we need to skip that position, right, character position, and go forward to check the actual equality I think that's pretty much for this hash map approach. So you can use another approach also. Let me show it to you also same for the same. Okay, so let me copy that. Okay, so we can, so in that case, in the earlier case we are using map, right? So but we probably so there is a concept called trie data structure. We can use that also. So trie data structure is nothing but it's a kind of tree, right? So let me take one tree, right? So let me copy this. So let me copy and copy, then again copy, then again copy, right? So using trie, we just store each and every character in a tree, right? So basically you can see, okay, so this is my starting, this is my root node, right? So basically it will be my root node, and in that, after that I will check, okay, B. So B is my first character, I am going to store it here. Then again I will see A, right? I will take another one. So I will take another one and let me copy that. So okay. So now I will say, okay, B, now I will store D, A here, now I will store D here, right? Now for the next word, right, DAD. So how we can store DAD? Again, I need to take two more, right? So let me take two more nodes. Okay, now let's store it. So at first I will store D, then I will store A, then I will store D, right? So this is how the trie data structure works, right? Again, I can take map also. So the last word is mad, right? So M, then again it should be A, D, right? So it should be M, then it should be A, then it should be D, right? Then you need to, so you can just think like a tree, right? So tree and leaf node. So and you can link this tree, right? So this is the linking, how it will look like. So let me complete that first. Okay, so it will look like this. So this will be a data structure, a dictionary. You can think like this. So this kind of data structure is called as trie data structure, and it is very helpful to this kind of scenario also, right? So suppose I'm going to add my word bad. So I will add it here, BAD, right? So at first I will check that is there any leaf node for my starting character? No. Then I am going to insert, create one new node and store that particular character, right? Similarly, for the second scenario also, we don't have any word called DAD, right? So I am going to create another separate node. Similarly for mad also, right? So this is how, right? So but suppose you have two common, right? So you need to search any word BA, right? Something like that. Then you can do that. So suppose probably, so let's add another one in the trie, right? So there is some word like ball, right? So it is like BALL, right? How we can insert it in the trie, right? So basically you can see, okay, my B is already exist, right? So B is already exist, A is already exist. So I will not going to create separate node for the same. But what I will do, but after that I will see, okay, there is nothing for L, right? So I am going to take two more. So I am going to create two more node, right? So one is for L, then again one is for L, right? So this is how the trie data structure insertion work, right? So basically at first, whenever we are inserting anything, we check that for that particular position, is there any node exist? If exist, then we are going to reuse that node, and I'll go to the depth, right? And whenever I see that there is no more matching node, then we are just creating or inserting new nodes in our data structure, right? So this is how the ball will store, and you need to maintain a flag for each and every node that it's the end of word, right? So basically this is the end of word, right? So you can write like this, okay, this is the end of word, and you can use the true or false flag, right? So this is how the insertion work. You can write logic for the same, and for searching also, right? You can do some similar thing like, so you can start from the root node and you can check that particular character is exist in any of its child node. If yes, then you should go to the, so basically you need to use the depth first logic, right? So you need to go to the depth and check that the total word is matching or not. If it is not matching, then you need to come back and check for the other possible combination, right? So that's a trie data structure approach. You can try it yourself in code, and if you still have doubt, you can ask me in the comment section. I think that's pretty much for this video. If you like this video, please subscribe to our channel. Thanks for watching. Bye bye.